let's look at this problem here. We're going to try to find the area underneath our x squared between 1 and 4. We are going to go ahead and start out with our x sub 0. Your x sub 0 always correlates to where you begin, which in this case was 1. Your x sub number of rectangles, in this case is 3, always correlates to the end of your interval, which in this case is 4. Left endpoint rectangles, and we're looking at left endpoint rectangles because the top left corner of your rectangle touches your curve. Says we need to start out with our sigma, k equaling 0, to 1 less than the number of rectangles. The number of rectangles was 3, so we go 1 less and we get 2. Then we got to come along and we got to have our function. Our function is our input squared, because that's what we have right here, our input squared. Then we need to go ahead and multiply it by our width. The width of each rectangle we would put here. Well, in this case, the width of each rectangle is 1. You can always get that by going 4 minus 1, which is 3, divided by the number of rectangles, which is 3, and 3 over 3 is 1. It's very easy to see in this problem, but that's the process you would use when you get to other problems. Now, we got to work on what we would put in here instead of x. That's related to this blue stuff right here. We have to figure out the equation of a line that goes from our point input 0, output 1, and goes to our point of input 3, output 4. So we'd have to find our slope. Remember, slope is rise over run. Subtract your y's over what you get when you subtract your x's. So you get 3 over 3, so we get a slope of 1. Plus, we're looking at the y-intercept of this line. Not the y-intercept of your original graph function, but the y-intercept of your line. The y-intercept of your line is what you get when you plug in 0. When you plug in 0, you get 1. This right here tells us what we're going to plug in wherever we had an x. So we're going to go 1. We're not actually going to use x. We're going to use our variable here, which is k, plus 1. Now, typically, people are going to simplify this a little bit. Still go k equals 0 all the way to 2. And they're going to just go a k plus 1 squared. And timesing it by 1 here doesn't change it. So this is what we would get for our left endpoint. Here we're looking at the same function going from 1 to 4, but we're dealing with right endpoint. Right endpoint is where the upper right-hand corner of your rectangle touches your curve. Now, notice this right here looks just like it did with the left endpoint. The only difference is, instead of starting out at 0 going to 1 less than the number of rectangles, we need to start out at 1 and go to the number of rectangles. So we're going to go, for our right endpoint, start out at 1, go to the number of rectangles, which was 3. Then you got to have your function, which was our input squared, x squared, and then multiply it by our width. This whole part right here after your sigma is the exact same thing it was after your sigma here. That part doesn't change. So this right here does not change, whether you're dealing with left or right. So all I have to do is recopy that and put it on the next problem, and I'd be done. So that's that special equation of a line I found that I plugged in for my x multiplied by my delta x, the width of each rectangle. We don't really have to go ahead and refigure all this out, because when it's the same function, same problem, just going from your left endpoint to your right endpoint, the only thing that changes are your two indices on your sigma notation.